Electric power. The equation for electric power, we're not going to derive this for you. We're just going to give it to you. Power is current times voltage. And the units, we know that current is amps, which is coulombs per second. And V is volts, obviously. And power is in watts. So a watt is a joule per second, because a volt is a joule per coulomb, and an amp is a coulomb per second. And so you can see the coulombs cancel here on the right side, leaving you with joules per second. So the unit for power is watts. This figure shows a non-ideal battery, a real battery of voltage E and internal resistance little r in a circuit that has another resistor, capital R. Let's derive expressions for the total resistance of this circuit. Whenever you have resistors in series, one after the other, then the total resistance is just going to be the sum of those, little r plus big R. The current flowing through the circuit, we're going to use Ohm's law, which says that V is equal to I times R, or another variation of that is current is voltage divided by resistance. The current throughout this circuit is going to be everywhere uniform, and it will have the value, the voltage of the battery, which is represented by this variable E here, divided by the total resistance, which is little r plus big R. So that's going to be the current flowing through any portion of this circuit. And the total power that's output by the battery, I can write it down here. Power is current times the voltage. Here we have an expression for the current, and the voltage of this battery is capital E. So if I take that expression multiplied by another E, don't I get E squared over the quantity little r plus big R? We're going to be dealing with resistance and current and power a lot here in upcoming videos, but that kind of gives you just a taste of what we'll be up against.